That kind of thing. Good evening, everyone. Hi. Mike, thanks.
Welcome to the data engineering track. And my name is Eliza, your host, and our co-host today will be Odessa. Before we proceed, we kindly request you to sign your phone and refrain from using the session. The session will last 45 minutes, and it will be recorded and available online in a few weeks. Our speakers will be open to taking questions. We encourage you to raise your hand. We'll facilitate a Q&A session to engage with the speaker directly. And today we have our guest speaker, Navjot Singh. He will be talking about serverless with BigQuery. Navjot is a cloud customer engineer at Google, where he helps digital native companies start their own data. He has been working in the data and analytics spaces for over 8 years. His previous role as a solution architect at a consulting firm, he helped with several customers in the Los Angeles area build their data platform on the cloud. Without prolonging the anticipation, let's give a warm welcome to our speaker.
All right, so I'm going to cut short the introduction. I'm going to start directly jump into the content. So today I'm here to talk about BigQuery as a modern data warehouse and its serverless capabilities. Before we go into BigQuery's capabilities, let's talk about why do we need modern data warehouse. As more and more companies are investing into data and AI initiatives, we see companies are running into several challenges. As you see on the slide, the first challenge is data is getting bigger and bigger. So data has grown with unprecedented growth in the last decade, and it is growing. But it's not just about the growth of the data, right? It's the unpredictable nature of the data. Data is coming into different formats. Data is coming into text files. Data is coming into audio files. Data is coming into video files. And also the data is coming in at different pace. Sometimes you need to do batch ingestion, but the batch ingestion is not going away, but the real-time ingestion is becoming more common. You need to transform data in real time to get the real-time insights from the data. The other one is data is spread across. Data is, if you're a multi-cloud organization across clouds, data is on-premise. If you're a hybrid company. The second challenge is data requires more than SQL. What I mean is the way we work with data is continue to evolve from several machine learning frameworks. Like every year there is a new machine learning framework coming, GenAI for an example. And then as I mentioned, stream processing is becoming more and more common. And also not just getting insights out of data. Now you are interacting with data using data-driven applications. If B2B SaaS company, you want to build analytics capabilities within your platform to share analytics with your customers. And there are several programming languages to interact with data. So that's why we see the rise of data engineers in this space, because there is more ways to interact with data and there's a requirement to do more with data. The third challenge we see is data needs to reach everyone. All employees, all of your partners, all of your customers, they need to access data, and that comes with challenges of how do you govern data, how do you put access control on data, how do you ensure security, and data is kind of crossing the boundaries of your organization. Share data with your suppliers, your logistical companies. So we see a lot of challenges and how these challenges can be solved with data warehouses. But let's talk about, before we talk about BigQuery, how BigQuery can solve these challenges, let's talk about why the legacy data warehouses are not able to keep up with the challenge and growth of it. Legacy data warehouses, which has been in the market for a long time, are not able to scale with the demand of the spike of the data. For an example, we were working with one of the major retailers, and they had a kind of infrastructure scalability issues during holiday peak season. So legacy data warehouse cannot scale along with the demand of the spike. And we were also working with one of the healthcare provider, and they had hurdles during enrollment season for their patients. And then legacy data warehouses are not able to stream data in real time, not able to unlock insights from data near real time. And if you want to do advanced analytics on top of that data, you need to get data out of data warehouse, push it to another system. That brings more challenges of data silos, security issues, access control issues. So there are a lot of challenges which legacy data warehouses bring up when we talk about in today's world's analytical. So how does BigQuery solve these problems? Before I start talking about BigQuery, any questions on this? So how does BigQuery solve this problem as a modern data warehouse? So because of BigQuery's serverless nature, it can easily scale or flexible in scaling along with spike events. You just throw in your data and start writing query. If there's more data coming, BigQuery will automatically provision resources to run your queries at any time. And we'll show that during demo. The other thing is combining different data sources. BigQuery supports a wide range of data formats, structured and unstructured. We'll go into more detail later. BigQuery has easy way of ingesting data into BigQuery. And sometimes just get insights from data without even moving data from the source. For an example, cross-cloud, you may have data on Amazon S3, Azure Cloud Storage, without moving data out of the system. Query data and get insights. BigQuery has real-time ingestion capabilities. You can stream data into BigQuery in real time and start getting insights in real time. So that's where a lot of Cloud 1.0 data warehouses also like this capability. But BigQuery has that capability. Machine learning, as I mentioned, anything like data warehouse, you need to get data out of data warehouse to do advanced analytics. But in BigQuery, you can write SQL, you can create model, train model using SQL without moving data out of BigQuery. So it's not creating a data silo, you don't need to build a data governance or access control by getting data out of BigQuery. And you can even operationalize your machine learning model inside. And the final, one of the most important, everybody gets the point security. In BigQuery, data is encrypted at rest as well as in transit. BigQuery is reliable, data is replicated across zones, so you have peace of mind. It has 4.9 SLA on availability, and also it has fine-grained access control, row level, column level security, and it is well integrated with your Google Cloud IAM rules. And except that, it has a great data sharing capabilities also, so you can share data with the partners and suppliers. So these are the some of the challenges legacy data warehouses face and how BigQuery solves these challenges. Any questions so far? Okay, let's talk about some of the BigQuery architecture. As I mentioned, BigQuery is completely serverless. It has been serverless since its inception. BigQuery is sits on top of replicated and distributed storage systems, and it is connected with the petabyte network to the highly available compute cluster. So when you are using BigQuery, you just push your data, start writing queries, and BigQuery will automatically provision resources at the back end. There is no warm-up. Virtual machine, you don't push your data and start writing queries. Okay, so as I mentioned, one of the challenges, data is multi-format as well as big. BigQuery, at BigQuery, we support many kind of data formats. Structured data, obviously every database covers that. We have support for semi-structured like JSON. We have support for Parquet, we have support for nested tables, which comes really handy when you have hierarchical data and you need to denormalize data. For example, you have customer and addresses, and if one customer has multiple addresses, how would you do it? So you will use a nested tables. So the rows of customers are not repeated when you're using multiple addresses for the same customer. We also have good geospatial support. We support many geospatial functions as well as some of the geospatial file formats also. One of the other keys is unstructured data. You can push your unstructured data into Google Cloud Storage and run analytics on top of it using BigQuery. So we support that using BigQuery. Any questions on that? Okay. So one of the other key capabilities which sets BigQuery apart from other cloud data warehouse provider is its multi-cloud capabilities. As I mentioned in the beginning, using BigQuery, you can have a single pane of glass across your data set if you have multi-cloud data in S3 or Azure Blob Storage on BigQuery. You can query that data from single control plane inside BigQuery. There are some ways, if you want to easily transfer data from S3 to BigQuery's native storage, you can just use this BigQuery Omni, which is our cross-cloud analytics capability, to just pull data easily into. So it makes it really easy to transfer any data, as well as if you don't want to transfer, you can just run analytics on top of data when it's in S3 or Azure Blob Storage, get insights without moving data, as everybody knows data. And it comes with a lot of challenges. Next slide is ingestion. As I mentioned, one of the ingestion is like the cross-cloud BigQuery Omni. You can install cross-cloud transfer data into BigQuery. BigQuery supports several ingestion methods. It does real-time streaming also using our API. But we have some of the connectors which are out of the box available. First one I would like to talk about is BigQuery Data Transfer Service. It's an easy and managed way to transfer data into BigQuery. We have several first-party connectors. For example, if you want to migrate data from S3 or Azure Blob Storage or Teradata Redshift or some of the Google first-party SaaS apps like Google Ads. So it has direct integration, and it can pull that data from those sources on a periodic basis based on your requirement. The other one is data stream. If you have any relational database and you want to copy that data or replicate that data into your data warehouse in near real time. So BigQuery has serverless change data capture service called as data stream, which can directly push data to BigQuery. So it's near real time on your relational database which serves the application. The other one is PubSub, direct to BigQuery subscription. If you have any messaging service or you have messages coming up from your application or any edge devices and you want to ingest those into data warehouse, you can publish those on PubSub, which is Cloud's messaging service. And from there, we have direct integration. So these are the only three we have listed here, but we have several other ways to ingest data into BigQuery. You can ingest using Cloud Console also, and we also have several SDKs. We have API, so there are several ways. So I'll just list a few which would be useful for the audience. Okay, so one of the other key capability of BigQuery is analytics. What I mean with analytics hub is data sharing capabilities. For example, if you're an e-commerce company, you want to share data with your suppliers, your vendors, with your logistic partners, or if they want to share data with you. So how do you do it? So within BigQuery, you can create an exchange and share a certain data set with your customers or with your partners. So it's an easy way to share data in near real time with your customer in a secure manner, so you can control the access also to which of the tables or which of the views you want to share. Let me go into a little bit architecture. So publisher creates a shared data set, or they can share existing data sets also. They can create views or tables into that data set. Then they can create an exchange. By default, exchanges are private, but you can make it public also. We have several data sets already available on the public from our partners. Once you create an exchange, you can share it with the subscriber, and subscriber can subscribe to that data set, and it kind of creates a linked data set within subscribers' project. And from there, they can start accessing. Publisher pays for the storage, and subscriber pays for the any kind of analysis or compute you do on top of data dependence. Okay, so these are the main capabilities on descriptive analytics. Like how do you get insights from the data? What's the architecture? But there is no presentation without AI/ML, right? That's the norm these days. So also BigQuery has built-in AI capabilities. But before we go into BigQuery's capabilities, what are the challenges we are seeing in the field related to ML? So there is a need to democratize AI/ML. And we are seeing currently ML or AI requires a specialized skill. So that's one of the challenges we see with the skill set. The other one is building AI systems are complex. You need to get data, you need to train data, you need to have infrastructure to train data, deploy models, and then you need to have infrastructure to put the prediction in place. And when you're working with the data, you need to put the proper access control on top of that data. So that also brings some of the challenges. So this is how the typical AI/ML workflow looks like. You have data, you ingest data into your data warehouse, you pre-process data, you export data into maybe a notebook or any other compute resource, and then you train your model using one of the machine learning framework in some kind of scripting languages like Python or R. Once you train the model, you need to deploy that model. It could be real-time prediction or the batch prediction tool. And then if you need to retrain it, you need to repeat this process again. But because you're exporting it out of data warehouse, you're training it, you're managing resources in several places. So you have several challenges of data governance, manage resources, and how do you host your models. So how do we solve this using BigQuery? So BigQuery has built-in, as I mentioned, built-in AI/ML capabilities. Using SQL, you can create model, you can train model, you can deploy that model inside BigQuery, and then run prediction using SQL. So everything happens in your familiar data warehousing language. So kind of whatever the challenges we see in the process, you don't need to export data out of BigQuery because your data is already in BigQuery. We are writing SQL to create model. You don't need to manage separate resources. Whatever model you're creating, you're deploying it within BigQuery. And then once the model is deployed, you are running just using SQL, you're running. So the BigQuery machine learning simplifies the whole process. Okay. So any question before we get into demo? Let's just see how BigQuery works. Okay. So, and we support many, in BigQuery ML, we support many models and features. If you have a need of classification models, you have list, regression, or some of the unsupervised learning models like clustering. And BigQuery is well connected with our AI platform called Vertex AI. Vertex AI is our unified AI platform to operationalize machine learning. You can write SQL in SQL code to create model and deploy model, but then you can operationalize it using our AI platform called Vertex AI. This list may not be comprehensive, so our docs we keep updating it here. Okay, let's see BigQuery in action. Any questions so far? Before I go into demo, how many people have seen BigQuery or worked in BigQuery? Okay, so when you log into your Google Cloud Console, this is what Google Cloud Console looks like. And go to BigQuery in analytics section, or I can directly search in the search bar. So this is how the BigQuery console looks like. On the left-hand side, we have several options. We have SQL Workspace. That's where you write all of BigQuery data transfer. But we can create a transfer and options. We have several first party, which will be available on the external data sources also. Partners, if you have Fivetran, SciSense, and then several other connectors are displayed, and you can directly connect the source from here and schedule the periodic loading to be and several first party. Google Analytics, but that integration. Analytics, from there you can integration and external. Scheduled queries is something you can, if you have a transformation query, you want to this is you can schedule it with scheduled query, analytics, listing, and to share data across organization or with other organizations. Dataform is recently went into GA. This is the service to build SQL-based transformation pipelines within BigQuery. For an example, you are putting data into Google Cloud Storage. Now, all of the transformation you want to do, you can do it using SQL. Why use other tools? You can use BigQuery's Dataform to build a transformation pipeline within BigQuery. For example, data lands from cloud storage into raw data set, and now you're running some transformation and putting it into a staging layer, and then finding curated layer. Dataform can stitch all those together. SQL transformation. And the other options are monitoring sources, data performing, capacity management. We have all of these to consume BigQuery. One of them is you directly write query, other you can put some threshold of minimum maximum resources and auto scale, ramp up and ramp down within. That's let's just start writing quick. So as a part of BigQuery, we have several public data sets we publish as a part of our Google BigQuery public data project. You can think of all sorts of weather data, US census data, several like bike share data, like New York City bike, you may have worked some patterns at some point. So all of the data sets are available as a part of BigQuery public data. Just to play around or maybe complement your existing analytics, for example. Those data sets are also available. So if you're at BigQuery and complement data with some public-based data, I would always check it's available. Okay, so now I'm going to show BigQuery serverless capabilities. In a way, I'm going to run 4 queries: small, intermediate, large, and very large. I'm going to show how you are seeing results in near real time, like really fast, but at the back end, how much time it is taking for BigQuery to process, but you're always seeing results instantly. So first of all, I'm going to execute a small query. And I'm executing a BigQuery public data set on a NOAA weather data. So so I'm executing a query to find the coldest places in US on the date of 15 December 2020. And we see most of the places are in our Alaska. So what I want you to look at is execution. So there are 2 metrics here. Elapsed time, that's the time users gets results back. So we got results instantly, 550 milliseconds. And slot time consumed, that's the machine time BigQuery scale out architecture took to run this query. It's pretty close. It took BigQuery 2 seconds to execute across parallelly in its cluster, and it gave us results in 515 milliseconds. Maybe let's execute another query, intermediate query. Let's increase the size of the query a little bit. We are running the query on, again, the same weather data set, and we are running it for the whole year, from 1st January 2021 to 31st December 2021. And we're trying to find the hottest places in the US. That's it. How much time it takes to run and how much time it takes at the back end to process. So we got the results for the places in US on the whole 2021, I guess, yes. And we see most of the places are Utah and California. So, but what I want to take a look at is, it took queries to 5 seconds to show us the results, and it took 10 seconds BigQuery scale out architecture to do at the back end. Still not a big deal. It's only double, but still it's faster compared to what that. Let's increase the scope of the query and run the project. So now I'm running query on a Wikipedia data set. That's the one with the other data set. Wikipedia publishes online all their page views every year, and we pull that data into BigQuery just to play with it. So what I'm trying to do is I'm trying to get the most viewed Wikipedia pages for 28th January 2021. And we are, so the way Wikipedia publishes these pages are for every hour, how many views for a particular page were. So they publish for every hour. What we are doing here is getting it for every hour for the date of 28th January. And we see for 28th January, first hour of the day and second hour of the day and third hour of the day, most viewed pages. What is each one? Actresses. Still, what I want you to take a look at is this metrics. We got result back in 1 second for BigQuery at the back end. It took BigQuery for a second. So, as we are increasing the scope of the query, the backend time is increasing, but the elapsed time for the user is not increasing that much. In this case, even it's better than the last query, and the slot time consumed is even more. Still, it's okay, 47 seconds to 1 second, 46 times faster probably. Let's try to increase the scope. By the way, this table has 53 Let's increase the scope of the query. Now we want to At the most, Wikipedia viewed pages by hour for the second half of 2020. So this query is going to scan the whole data set of 53 billion, but the data is partitioned. So BigQuery has partitioned, so it only scans partition if you read the partition column in the variable class. So I'm going to run this query. Let's see how much time it takes us to give us the result and how much the backend time takes the machine time to run this. Okay, so for the second half of 2021, the execution detail gave us result in 12 seconds, but BigQuery serverlessly scaled out the resources at the backend. Time consumed. Even though we are running a large query, we're not seeing much differences in elapsed time or result time. So BigQuery is automatically scaling out or provision resources capabilities or auto scaling methods. This is the serverless capability. We have 30 more minutes. Any questions on this?
Yes. Can you please re-explain the slot time consumed and what does these 4 hours look like in the back end? Because I'm seeing that this is like instantaneous.
Yeah. So BigQuery has slots. The concept of slots is a virtual CPU.
Okay.
So how much time it took at the machine time it took at the back end for the slot?
Okay. Oh, got it.
It's a computational capacity.
So, on the similar to that question, does that mean if you run it on a normal database, this would be the time to run the query, or what? The 4 hours?
It depends on the database, right? Half of the data set. BigQuery at the back end, it took this one. That's the calculation we push.
Right, but you're getting the result in 12 seconds. That's the advantage of BigQuery. So, yeah. Another question: is there any optimization parameters for once you put your data, like indexing on columns, or no? There's no such concept.
No, we do have, and that's what this table has. So you can partition your data. If you're ingesting data, you can partition your data by date. For example, every day you're pushing data, or incrementally partition data by date. And that's where if you use that date column in a where condition, it will go and find only data from that partition. So that's the one thing you do. Another thing is clustering. Within a partition also, you can cluster data based on the columns you provide. So partition column, where condition.
So now if I change my query, the where close to a different column, that date, maybe some other dates you have.
Yeah, but this table, sometimes because this table is huge, you don't want your analyst to run unnecessary queries on that table also. So in certain scenarios, the column you partition with, you can put a restriction in the BigQuery table. That column should always represent you. So if I don't use that date column in this one, we will not run.
Let's say that you want to run a different query, or you want different workflows. Do you have to reinsert your data, or it's enough to ask for a different partition? It processes all of that, gets back to you, and it's ready, or how does it work?
If the data is not partitioned based on the column you're using, you don't need to reinsert data. It will run query, but the query performance will
But then how would you partition on a new column? What is the process?
You create a new table and then insert data from existing table into that. That's the thing of it. And that's a simple create table as insert from this table. Create table and then easily select data from this table and insert.
So how, based on the like 53 billion rows, how long does this select insert takes time?
I think we need to test it, but it's gonna. I don't think it's gonna take that much. This is
One last question. So let's say you have your data. I know this is like for analytics, and let's say that you have more data coming. Right? Insertion. Let's say you want to insert your data on this table, partition by date. It's the process that are you going to be able to use your data that you just inserted, or there's some time lapse?
That's a good question. BigQuery has two main methods to this data. One is batch, where you data in batch fashion of streaming data. So if you're streaming data, it's instantly available while batch while the data is being written. But if you have a real time scenario,
Thank you.
okay, we still have 7 minutes. Any other questions?
You were talking about running unnecessary queries. Does that get charged to the consumer? Running of that kind of account? If I have a BigQuery account, I'm paying for each and every one of those queries.
We have two pricing models. One is on demand, where you pay by per query and how much data your query is processing. That's the most straightforward model. Another model is you can put the capacity, like as I mentioned, this gentleman has questions on slots. You can put as slots BigQuery without a scale. You can say, I'm going to run queries in this project, and this, you can create a reservation. This reservation should use 0 slots as a minimum, and 500 slots as a maximum. So when you run a query, BigQuery will start allocating slots to that query, and it will auto scale between 0 to 500 based on the requirement of the customers of that query. When the query is run, completed, it will start ramping it up. So it will auto scale between these predefined minimum and maximum.
So it'll be slower overall, but I just pay less because I'm capping it.
Pay less and pay more in a query-based, and the additions model depends on the workload. Most of our customers, they start with on-demand, and when they run on-demand queries in the capacity management, they can take a look if the slots will be a better solution for them. So they can see a slot estimator. If they're paying more on the on-demand model, and they'll be better off on the capacity with the solution. The first way is to start with on-demand. Based on your usage, move to the
So would this type of slot usage make more? Oh, sorry.
Make more sense once you realize how much slot time you actually need, and if you have more stable needs, let's say, rather than on-demand applications.
Yes, yeah. You start with on-demand most of the cases. You see your usage pattern, and then start doing additions, reservations based on the slot time consumed. Even if you run on-demand queries, whether you're paying by on-demand, it still show you how much slot you're using, and metrics will start to help the slots. So it depends. Some of the workload may be cheaper on on-demand compared to really expensive on the slots. And you can mix and match both also. For example, if you're running a batch query, you're transforming data. It doesn't require instant like a query results. You're running process overnight in a batch fashion. You can run it in a slot and it should only ever stay between these limits. And for a certain workload, you have on-demand cheaper, and performance for you is better on-demand compared to slots, performance and pricing. You can put those workload on on-demand model. So you can mix and match. Within reservation also, we have different kind of standard enterprise and enterprise plus. Has different kind of features as well as the number of slots you can reserve, as well as what kind of workload you have. So you can mix and match all of these. What makes sense for you?
Okay, thanks.
What's the use case that you would recommend BigQuery over other Snowflake?
That's a good question. Obviously, we don't bash our competitors, so I'm not going to say like, oh, why it's good. Like, there are studies around it, given the but compared to relational databases like Postgres, I can talk about it. Relational databases are open storage, and they are better suited for write application and certain kind of query pattern, while BigQuery as a data warehouse is most for having an aggregated queries on large data set. That's where the data comes from.
BigQuery has better integration with other Google data products.
Yeah, so BigQuery, not just other Google products, as I mentioned, we have integration. But BigQuery has better integration, or it's well integrated with our other data processing. These are another real-time data processing. So that's also really good. They get data from other sources also. Any other questions? Thank you. Very good. Thank you for joining.
Everyone for joining us.